Welcome back to Operating Systems Crashcast. I'm Victor, and today we're diving into an essential topic in CPU scheduling criteria. Sheila, why don't you kick us off by explaining why these criteria are so important?
Gladly, Victor. Scheduling criteria are crucial because they help us evaluate the effectiveness of different CPU scheduling algorithms. They provide metrics that allow system designers to make informed decisions about which scheduling approach best suits their needs. It's like having a report card for scheduling algorithms.
That's a great analogy, Sheila. Before we dive deeper, let's quickly outline the main scheduling criteria we'll be discussing today. We have CPU utilization, throughput, turnaround time, waiting time, and response time. Each of these plays a vital role in assessing scheduler performance.
Absolutely, Victor. Let's start with CPU utilization. This criterion measures how busy the CPU is kept. Ideally, we want to keep the CPU working as much as possible for maximum efficiency. Think of it like keeping the engine of a car running smoothly without unnecessary idling.
Great explanation, Sheila. Moving on to throughput, this measures the number of processes completed per unit time. It's similar to how many customers a restaurant can serve in an hour. The higher the throughput, the more efficient the system is at processing tasks.
Exactly, Victor. Now let's talk about turnaround time. This is the total time from when a process is submitted to when it's completed. It includes waiting time, execution time, and I/O time. In our restaurant analogy, it's like the time from when a customer enters to when they leave after finishing their meal.
That's a helpful comparison, Sheila. Waiting time is closely related to turnaround time, but it specifically measures how long a process spends waiting in the ready queue. In the restaurant scenario, this would be how long customers wait before being seated or served.
Precisely, Victor. And finally, we have response time, which is particularly important for interactive systems. It measures the time from when a request is submitted until the first response is produced. In a graphical user interface, for example, it's the time between clicking an icon and seeing the application window open.
Excellent breakdown, Sheila. Now, here's where it gets interesting. These criteria often involve trade-offs. For instance, optimizing for high CPU utilization might lead to longer waiting times for individual processes. How do you think system designers balance these competing goals?
That's a great question, Victor. It really depends on the specific needs of the system. For example, in a batch processing system, high throughput and CPU utilization might be prioritized over response time. On the other hand, for an interactive system like a desktop computer, response time becomes crucial for user satisfaction.
Absolutely right, Sheila. It's also worth noting that these criteria can have real-world implications for everyday computer users. For instance, poor response time can make a system feel sluggish and unresponsive, even if it's actually processing a lot of tasks in the background.
Exactly, Victor. And that's why understanding these criteria is so important for software developers and system administrators. By optimizing for the right criteria, they can significantly improve the user experience and system efficiency.
Well said, Sheila. As we wrap up, let's recap the key points we've covered. We discussed 5 main scheduling criteria: CPU utilization, throughput, turnaround time, waiting time, and response time. Each of these provides valuable insight into scheduler performance, but they often involve trade-offs.
That's right, Victor. We also highlighted how different types of systems might prioritize different criteria based on their specific needs. Understanding these criteria and their implications is crucial for designing and optimizing operating systems.
Thanks for joining us for this deep dive into scheduling criteria. Stay tuned for our next episode, where we'll explore specific scheduling algorithms and how they address these criteria. Until then, keep on computing.